Ladies and gentlemen, thank you for joining me today. Today, I want to address a question that has puzzled scientists for decades. Does the electron really rotate the nucleus? We have all seen the classical image of an atom. A nucleus surrounded by electrons orbiting like miniature planets. This model, known as the Rutherford-Bohr model, and has been taught in school days for many years. However, modern quantum mechanics challenges this view. The truth is, electrons do not actually rotate around the nucleus. In a classical sense, we consider electron is rotating the nucleus, but we actually describe their behavior using a concept called electron orbitals. In quantum mechanics, electrons are described as existing in a region of space called orbitals. These orbitals represent the probability of finding an electron at a particular location around the nucleus.
But if electrons don't really rotate, how do we explain the stability of atoms? And how do electrons stay in their orbitals?
Great question. The stability of atoms is due to the balance between the attractive force of the positively charged nucleus and the repulsive force between electrons. This balance is maintained throughout the wave-like nature of electron, which allows them to exist in specific energy levels or shells around the nucleus. Electrons occupy these energy levels or shells based on their energy, with the lowest energy levels closest to the nucleus. The number of electrons in each shell determines the atom's chemical properties.
So, if electrons don't rotate, then how do they move within these orbitals?
Electrons move within orbitals in a complex manner. They exhibit wave-particle duality, meaning they can behave as both waves and particles. Their movements are described by quantum wave functions, which provide probabilities of finding electrons in specific locations. This behavior is fundamentally different from classical rotation. These wave functions give us information about the electron's position and momentum, but they don't correspond to a simple circular motion. It's a complex motion that yet scientists haven't determined, and it has not been yet discovered.
Is there any experimental evidence supporting this?
Yes, indeed. Experiments such as the double-slit experiment and electron diffraction have provided strong evidence for the wave-like nature of electrons. These experiments demonstrate that electrons exhibit interference pattern, just like waves do. In conclusion, While the image of electrons rotating around the nucleus is a useful tool for teaching, it does not actually represent the behavior of electrons. It's just a tool for teaching. But in actual nature, electrons exist in orbitals and move in a wave-like manner, with their positions described by probability distribution and other functions. Understanding this quantum behavior is crucial for our understanding of atom and its structure, and also the chemistry. As we go deeper and deeper, puzzle resolves and we get answers, but the more it becomes complex. I think you have understood that only for education purpose we teach students that atom revolves around the nucleus, but it's not. The atom is not revolving around the nucleus. It's in a probability space, and its exact path of motion is indeterminable. Thank you for all of your attention. I hope this clears up any confusion about whether electrons really rotate the nucleus or not. Thank you once again.